In this video, we have compiled a list of 28 common types of filters. With our understanding of LC resonance, we can now logically determine whether these filters are high pass, low pass, band pass, or band reject. For the capacitor, its impedance is negative J times 1 over omega C, and it changes with a frequency. When the frequency is low, its impedance is high, while at high frequencies, its impedance is low. If we have a capacitor connected to a signal source on the left and a load on the right, what type of filter it is? Of course, it is a high-pass filter. This is because the capacitor's impedance is lower at higher frequencies, allowing higher frequency signals to pass through more easily. For an inductor, its impedance is J omega L, and it changes with frequency. When the frequency is low, its impedance is low, while at high frequencies, its impedance is high as well. So, is it a high-pass or low-pass filter? It is certainly a low-pass filter. This is because the inductor's impedance is lower at lower frequencies, allowing lower frequency signals to pass through more easily. Let's see the scenario that the capacitor or inductor is shunt to ground on the signal path. For the capacitor, the lower frequency signal will not want to take the path of the capacitor to ground, so the lower frequency signal will be more likely to run to the output load. On the contrary, the higher frequency signal will want to take the path of the capacitor to ground. So this is a low-pass filter. For the inductor, it is of course a high-pass filter, because the lower frequency signal will want to take the path of the inductor to ground. On the contrary, the higher frequency signal will want to take the above path to the output load. Okay, from now on, in each circuit presented, I will ask you to pause the video for a moment and consider what the answer is. Now let's examine this series capacitor and shunt in inductor circuit. Can you tell if it is a high-pass or low-pass filter? It is, in fact, a high-pass filter. This is because low-frequency signals tend to avoid the high impedance path above and instead prefer the low impedance path below, leading to ground. Conversely, high-frequency signals favor the upper path toward the output load. The circuit on the right is constructed with a series inductor and shunt capacitor. Can you tell if it is a high-pass or low-pass filter? It is, without a doubt, a low-pass filter. This is because low-frequency signals tend to follow the upper low impedance path towards the load and avoid the lower high impedance path leading to ground. Now, this one circuit on the left, it is a shunt inductor and series capacitor structure. Of course, it is a high-pass filter, because low-frequency signals like to take the low impedance path for the inductor to ground, and they don't like to take the high impedance path of the capacitor to the output load. On the contrary, high-frequency signals will prefer to take the above path to the output load. The circuit on the right features a shunt capacitor and series inductor. It creates a low-pass filter. This is because low-frequency signals tend to avoid the high impedance path of the capacitor leading to ground, and instead favor the low impedance path of the inductor leading to the output load. In contrast, high-frequency signals prefer the path below leading to ground. Let's now consider the scenario of a series LC circuit where there are 4 filter options to choose from. They are low pass, high pass, band pass, and band reject. What type of filter does the circuit on the left represent? It is a band pass filter. This is because at a particular frequency f0, the 2 components are of equal reactance, resulting in resonance. Since these 2 components play with themselves at frequency f0, it is as if the source no longer needs to supply them with energy. As a result, they become transparent, allowing the signal of frequency f0 to pass through them unhindered. Thus, this circuit functions as a bandpass filter. Moving on to the circuit on the right, it features a parallel LC circuit that is connected in series on the path between the source and load. When the circuit is at the resonant frequency f0, the 2 components interact with each other in such a way that they no longer require any external energy. That is, they are open circuit. This causes the circuit to function as a band reject filter. Now, suppose we take the series LC circuit and shunt it to ground. What type of filter does it become? This configuration functions as a band reject filter. This is because at resonance, this path acts as a short circuit. Consequently, at the resonant frequency f0, the signal of that frequency will be short-circuited to ground and unable to reach the load. Therefore, it is a band reject filter. Now, if we take the parallel LC circuit and shunt it to ground, what type of filter does it become? This circuit now functions as a band pass filter. This is because at resonance, this path acts as an open circuit. Therefore, at the resonant frequency f0, the signal of that frequency can reach the load directly. Consequently, it serves as a band pass filter.